Okay, let me begin where we left off. We learned that integer divided by integer is integer, and therefore you won't get the right answer, if the answer is fractional. So here's another example of that. If I write 17/5, so no matter what the variable type on the left side is, it doesn't matter. The division here is integer by integer. So that's what you need to look at. Is it integer by integer or float by float, or that division itself has operands that are integers. That's what matters. So that means this will produce integer number, and then when you assign it to float type variable, it'll be converted to float. So the answer will have a decimal point, but that doesn't mean you have correct answer. So if you have this statement will have wrong value stored in X because you're dividing integer by integer. So if you want the right answer, then you have to change the data type of one of the data. For example, if I write 17/5 point, that'll work. Or 17.5, that'll work. You need to make that adjustment. Or you can make 17.5 point. They both can be float, or at least one of them must be float to get the answer right. So let's move on to some exercise. So just look at the first one. That's all we need. What will be printed by this? Anybody?
Two 2.5.
No, incorrect. Oh, I'm sorry. No, you're right. I didn't realize n is float. N is declared as float, so therefore the value n will have is 2 point, and therefore this division will be done correctly because n is 2 point, m is 5, so it'll be 2.5. Okay, so that's all we need on that. Cast operators. Now you have seen in this previous example that we often need to manually convert a number to a float type or int type as needed. So if there is a number like 17, we can just throw in a dot behind it and that'll do it. But what if it is variable? So you have a variable that's holding integer value, but you need to temporarily convert it. 1 second. So I don't see a memory cell has a 35. I don't want to 35 and it's integer type. I want to keep it as integer type. But when I am doing a division, temporarily I need to convert the value to float. That can happen, right? You're writing M over N. Let me go back to the previous one of those examples. See, in this warm-up exercise 3, look at the last one. Int m equal to 9, n equal to 2. Those are integers. So 9 and 2 are the values. I don't want to change them. I want to keep them integers. But in this division, the division is going to go wrong. So is there any way I can make this division go right and still keep the integer variables as integer variables? There are times when we need to do that. So that's why they have this cast operator. Cast operator is a operator. Basically, the name of the operator is the data type. Float in parentheses or int in parentheses is an operator that you can throw in front of any variable to say convert this to float or int, whatever you want to, for now, just in this expression. So if I write float 35, that would be 35 point. So float in parentheses becomes an operator that'll convert it to 35 point. But if it is 35, we don't need this operator. We can just throw in a decimal point behind it. We need this operator only if it is variable. You cannot put a decimal point behind variable. So that's why you need this. Similarly, if you want to convert a memory cell variable to int temporarily, then you have int in parentheses. So these are called cast operators. Let's see an example. 3.0 divided by 2.0 will be 1.5. 3.0 divided by 2 will be also 1.5. Float 3 over 2 is also 1.5. But like I said, if it is 3, you don't need the float, but it'll be fine. It'll work. We could have just written 3.0. But this float t equal to 3 over 2, this wouldn't work right. 3 over 2 will be a 1, not 1.0, 1.5. So t will have, in this case, the t will have 1.0 stored in it, which is wrong value. So let's look at this second example. K, L, M are integers, float DE, K gets a 7 stored in it, L has a 3.5, K over L equal to D. This will work fine because L is a float type number. Oh, wait, sorry about that. Now, L is declared as int type, and therefore, what you're storing in L is 3. So this division, K over L, it's 7 over 3, is going to be wrong because it doesn't, both of them are integers. So even though float D is float type, that doesn't mean this division will work right. So division is going to produce 7 over 3, which is 2 integer number, and D will get 2 point as the value stored. So D will have a 2 point. Now, if I write float K over L, so then I'm dividing 7, K has 7, yeah, 7 point. Now the value used here in this division will be 7 point. Divided by L, which is 3.5, and that division will work right, and it'll produce 2.333. So E has 2.333. And then M over float L, that will also work right. So you need to convert but one of them to float to make it produce the right results. So dividing 7 by 3 point now, and so that'll produce the right answer, 2.333. But then you assign it to M. M is integer variable, so you're only picking up 2. So M will have a 2. So D will have 2 points, E will have 2.333, which is the correct answer expected. M will have 2. So it looks like all of these are doing a division, the same division, but they're not all going to produce the right answer. The first one produces the wrong answer because you're dividing integer by integer. Third one produces the wrong answer because you're assigning to an integer variable. The division goes right, but you're assigning to integer variable. So the answer is not going to be stored correctly. Only this will work right. Okay, so let's move on. So if A is a float type variable, you assign 4.85, and if you see out int A, that'll print 4. Basically you're saying just print integer part of that number, convert it to integer and print, which means print integer part, which is 4. Similarly, if n1 has 66, you assign 66, and then see out char n1. So you're saying convert the value of n1 to a character and print it. That'll be B. So you can convert at printing time. So you can store a number in a memory and get it out as a character just by using this conversion method, char in front of it. So they'll convert it to a character and print it. So you can, during printing time, you can convert to whatever you want. All right. The arithmetic expressions. My title is missing. That's what I was wondering. Something happened. The arithmetic expressions and order of precedence. That's the topic next. So to understand that, let's look at this example. A, B, and C are float, and A, B, and are getting 10, 2, and 5. So they will be actually stored. The actual value stored in A will be 10 point. Actual value in B is 2 points. N has 5 point. Now you are dividing. Now division will be fine because they're all float type values. So the question is this going to do this division first and then multiply? See, there's no parentheses anywhere. So if you do it as a over B multiplied by N, then it'll be 10 over 2 times 5. They're all decimal, they all have decimal points. I missed here. But it's 10 point actually over 2 point times 5 point. That's what you're doing. They're all float type numbers. So that will be 25 point if you do the division first. If you do the multiplication first, then it will be 10 point over 10 point. 1 second, someone just came in. Sorry. So if you do it, if you do the multiplication first, then it'll be 10. B times N is 10, and the A is also 10, 10 point actually. So the answer will be 1. So which one is going to be produced? That's the question. Is it going to do the division first or multiplication first? So obviously there is a certain rule that the system has to be given as to which operation it should do first. Otherwise, there will be, I mean, the computer system cannot work with ambiguities. Everything has to be clearly told. So therefore, there are some instructions that the system is going to go by as to in what order arithmetic operations should be carried out. And that is what we need to go over next. In what order is it going to do the operations? Okay, so here is the rules of order of precedence. Basically, if you have parentheses, then that will be done first, always. Unary minus will be next. Now, what is unary minus? The minus is an operator when you put it in between two numbers. It's a subtraction. But minus is a unary minus if you put it in front of a variable or number. So let me go to the board and hold on. Someone just came in. Okay, so let me write on the board. If I write 5 minus 3, then the minus is subtraction. If I write minus 5, the minus is now unary minus. It makes the number negative. So you can do that. You can use that minus in the same way for variables also. So if I write m minus n in my expression, then it's a subtraction. If I write minus m anywhere, then minus is unary minus, and it will change the value of m to negative. You're negating the value of m. That's what it is. So can I write something like this? X equal to minus m times n plus k. Yes, it means negate the value of m, multiply it by n, and then add k to it. Now, again, the question is which operation will be done first. Again, if it does the plus first, then it'll be a completely different answer. If it does the multiplication first, that'll be different. So we need to pay attention to the order. After the parentheses, the very first operation it will do is unary minus. So any minus in front of a variable will be first evaluated and the number will be changed to negative or whatever. And then, sorry, multiplication, division, and modulus, they belong to the same level. What if there are more than one of those? There is a division and a multiplication in the same expression, then it'll do the left one first. So that's the part you need to remember, left to right for multiplication, division, and modulus, if there are more than one, even if they are mixed like this. X equal to M times N divided by K. So this will be done as, which one will be done first here? The multiplication or division? Anybody?
Multiplication.
The multiplication will be done because it's on the left. So multiplication and division belong to the same level of precedence. But if there are more than one of those, then it'll do the left one first. Addition and subtraction will be the last, plus and minus. Now, these are the basic arithmetic operations. There'll be many more operators we are going to be learning. So as we learn those operators, we will understand where they belong in this list. So right now, this is all we need, and let's work with those and apply to different situations. So here's an example. I have int k equal to 10, m equal to 5, n equal to 2. They're all integer type. A equal to k over m over 2. Two divisions are there. So when there are two divisions, it'll do the left one first. Of course, you can always throw in parentheses to make sure it will do exactly what you want. But very often, people don't write parentheses. And parentheses is not required as long as you follow, you understand exactly what will be done, exactly how the system will interpret your expression. So this will be, the k over m will be done first here, and therefore for 10 over 5 will be a 2, and now you're dividing that 2 by another 2, so it's a 1, and they're all integers, so the answer will be 1, and a will have a 1. Here in plus k over m, you may have expected to do the addition first, but you're not going to have that. The division will be done first. So if you intended to do addition first, then you have to have parentheses. So it's going to do the division first. So k over m will be 2, and that will be added to n, which will make it 4. So b will be 4. Again, like I said, if you don't want the division to go first, then you have to put parentheses around the plus to make sure that will be done first. Okay, so let's do this warm-up exercise. Notice that they're all integer variables, and also remember the modulus operator applies only to integer variables. So if there is any expression with modulus operator operating on a float type variable, it'll be error. So your answer should be error, not a number, if that's the case. But here, A, B, C, they're all integers. Only the D is float. So when you have an answer, I like to hear it. Go ahead.
Two.
Okay, one student says 2 will be the answer. Any other answers?
I was gonna say 2.
I'm sorry, I didn't hear that.
I was gonna say 2.
2, okay. Let's wait for everybody to finish.
2.
Okay.
I think I'm getting 2 as well. Yeah.
Why is everybody getting 2?
I got 5.
That is also not quite right. 2 is completely wrong. I don't know why you're getting 2. Try again.
Isn't modulus the remainder?
The modulus operator produces remainder, yes.
Yeah, so
Remainder of dividing.
3 plus 7 is 10. 10 divided by 2 equals 5. And then 14 plus 3 is 17. 17 divided by 5 is remainder 2.
But there's a plus C over 2.
Is it 5 point?
5 point. There it is. One student got it. So yes, A plus B modulus B will be 2. Agree with that. But if we are adding C over 2 to that, are you ignoring that? Okay, so A plus B, yes, one student got it right, very good. Too many of you got it wrong, so
I ran the code and I just got 5.
you must have mistyped something. A plus B will be 14 plus
They're not.
14 plus 3 is 17. 17 modulus B means dividing 17 by 3 and getting the remainder. 3 goes into 17 5 times with the remainder of 2. So therefore, this whole expression equal to 2. All right, everybody's with me so far? Now, C is 7. C over 2 is 7 over 2, which is 3, not 3.5, because they are integers. C and 2 are integers. So that's a 3. You're adding that 3 to the 2. The total is 5. The total expression value of this expression is 5. Now, when you store it in D, it's 5 point. That 5 point is what you're printing. Okay. Any question?
What's the difference?
What do you mean difference? There's difference between 2. Some of you gave an answer 2. That's wrong. It's 5. 5 point actually. Anybody needs more explanation on that? Okay. Moving on. If you want to make sure it'll do exactly what you want, then you need parentheses. So if I write A slash B slash C in my expression, it will be done as A over B first and then C, and then divide by C. If you don't want that, then you have to put parentheses. So here's an example of algebraic expression, AC over B. If you want AC over B to be written in C++, you have to write A over B times C or A times C divided by B. Either one is going to work right, because algebraically A over B multiplied by C is same as A times C over B. Now, if you want A over B C, A over B times C, then you definitely need parentheses, because if you don't put parentheses, it'll do A over B first, then multiply by C, which is wrong. If you need to write AB squared, then it's A times B times B. There is no exponent in C++, and remember that. Do not use. I noticed, I explained to you one time, there is much later in the course, we will learn a way of doing exponent, because when you have large exponents, you have to have some way of handling it. You cannot do multiplication if it is very large number of very large exponent. So therefore, there was, there's something available in one of the libraries. It's not part of C++. It's one of the library feature is going to be available. And I noticed one student was using that feature in the program. Let me warn everybody, you have to follow the course in the right order. you're not supposed to use anything advanced that we haven't discussed in any of those homework, any of the homework or project. You have to limit yourself to what you have learned in class. Remember that.
Which one are you talking about?
There was one student using the POW function, which is a function that is in the library that will be coming up much later in the course. Only after we learn about it, you can use it. At this point,
Oh, okay.
you should not use it. Okay, there was one student using it. He may have gone ahead and learned more. I understand that's nothing wrong with learning more, but there is a reason why we want you to stick with whatever you have learned at this point and then learn advanced things. And so at any point in time, you use only what you have learned at that point. Do not use any other advanced features. All right, let's do this warm-up exercise. This is, very heavily depending on the answer on this of these expressions will heavily depend on the order of precedence that you follow. You have to follow the order of precedence. Okay, so let me see if for this first expression, what value you would compute. All the variables are flowed, as you can see. So you don't have to worry about conversions here. No conversions are happening. Just pay attention to the order of precedence.
I got negative 12.5.
Negative 12.5. Okay. Anybody else?
I got a negative 11.5.
I also got negative 11.5.
Okay. All right, we have two answers. Let's see, anybody else? All right,
Negative 11.
I'm sorry, what's that again?
Negative 11.5.
Negative 11.5, okay, very good. Negative 11.5 is correct. So let's quickly go over it to make sure everybody understands it. The operation done very first is parentheses, so E minus F will be computed, and that's going to be 2. So right here in place of E minus F, you'll have a 2. Right after that, it's going to go to the minus A operation because negation has to be done next. So the A will be, A is 24. So this minus A will be recognized as minus 24. And the next operation is this division. So minus 24 will be divided by B, producing negative 4. And next operation is this multiplication. Negative 4 times 4 is negative 16. After that, it'll do this division of 9 divided by 2, which is going to be 4.5. And so now finally 4.5 will be added. The addition is the last operation. It'll be added to negative 16, which will produce negative 11.5. I think the student who gave me negative 12.5 probably made a arithmetic error in the last step. But anyway, the answer is negative 12.5, negative 11.5.
You are correct. I made a mistake.
Okay. All right. we don't need this next warm-up exercise. Moving on. That finishes section 2.3. The remaining problems in 2.3, the even numbered problems in 2.3 will be part of the homework. Let's move on to two point four. 2.4 is about input through keyboard and interactive programs. The data will have to come through input on the keyboard, and also the program will be interacting with the user. You know, that's the kind of programming you're going to learn next. So let's understand first why we need this. You know, what's wrong with the way we wrote programs before. Now, this last project I gave you was, you know, elementary project. It's just to get everybody started, you know, to give you a jump start. That's what it was, to get yourself familiar with the compiler and all that. So the projects will, as we proceed, the projects will become harder and harder, you know, that the programming is not as easy as that last project was. There's a lot more to it. So let's understand here why we need to abandon the way we wrote program in the last project. Let's look at this example. Let's say I want to add two numbers. So we wrote the program in the last project and in the last section by assigning data to the variables within the program like this. Num equal to 23, rate equal to 35, and then introduce the variable sum to hold the sum of them. And then you say sum equal to num plus rate and see out the sum. Okay, so it works fine. It will add the two numbers, 23 and 35. But then if you look at the value of this program, it has zero value, because you know, can I give this program to somebody and say, here, I have a program that'll add any two numbers you want to add? No, this program is only good for adding 23 and 35. Only if anybody wants to add 23 and 35, they can use my program. That's very, very limited use, right? Extremely limited. So almost zero value for this program. If I want to be able to give a program to somebody and say, here is the program I wrote, it's useful for you, then it has to be able to add any two numbers that user has, that person has, right? Only then it'll be of value. So program should be written to work for any data, not for two specific data. That's the thing. I'm going to compare the situation to this. You know, when they build a car, they didn't build a car for those who can repair it or fix it. You know, the people who drive the car should be able to drive without having to know anything about it. So if you write the program this way and give it to somebody, and you know, and say this program will add two numbers, yeah, that person can get two numbers added using this program only if he or she can go into the program and change these numbers to whatever they have. So they have to know what a program is and where the data are and how to change them. So that's like expecting them to know the mechanism of something you manufactured so that they can go in and modify it before they can use it. That's not the way it should work. When you build a car, the car should be, the driver should be able to drive it without knowing exactly how the car works or without knowing anything about the mechanism. So therefore, the program should be written to work for any data that the user has without the user having to go into the program and modify it. That would be too much to expect from a user. You know, you have been using word processor without knowing anything about it, anything about how it works. So that's how it should be. So when the program is running, we should write the program in such a way that when the program is running, it should ask for the data. It should ask the user to enter the data so that user can enter the data he or she has, and the program will operate with on those data to produce the answer. So whatever the operation program is going to do, it will do that operation, but it should be able to do it for any data that the user has. So that's how the program should be. So how do we do that? There is a way. There is cin object provided in the language. It would get data from user. That's what this variable will do. So if anywhere in the program you write cin and an arrow pointing, you can see that the arrow is pointing a different direction from C out. 1 second, Patrick B. If you remember from before, the C out statement has the arrow pointing this way. And if you put a variable val, something like val, this means write the value of the variable val on the screen. If I write cin and the arrow going the other way and val, this means get data from user into the val, into the variable val. That's what it means. Get data from the user. When this, if this is in the program, if we have this within the program, then when this line is executed, the system will stop everything. It won't proceed with your program. It'll just wait for you or anybody using it to enter a data. So whenever this line is executed, it'll wait for user to enter the data, and user will have to enter the data and then press enter key. Only when the user presses the enter key, it'll take that data, whatever entered in the keyboard, assign it to this variable, and then it'll go on to the next line. So it'll go on only after the user types the data and presses the enter key. Enter key is the key. Then it'll go on to the next line of the program. If you have two cin statements like this, then when this is executed, it'll wait for the number or character, whatever the user will enter. And then it'll assign that value, whatever he entered, going into the val. Then it'll go on to this line where it'll wait again. So now the user will enter the second number. So if there are cin statements, every cin statement will wait for a number to be entered. And only after the number is entered and the enter key is pressed, it'll move on. Okay. So how does it work in a program? Well, I just explained how it works. So how do we use it in a program? So here's an example. So if I write this program int num1 and then cin num1, cout num1, this will basically just reflect whatever the user enters. When the cin num1 is executed, it'll work as a complete program. You can run it. When this is executed, it'll wait for the user. So user enters a number, and when the user presses the enter key, it'll print that number on the screen. So whatever you enter will be printed again. That's all this program does. But can you see one little problem? Let's say you give this program to somebody and say, this program will reflect whatever the number you type. All right, so that person is running the program now. And when the program runs, what do you think will happen on the screen? It doesn't take any time for the system to get to this line. When the system gets to that line, it'll just wait, doing nothing. So the user, if he or she doesn't know what's going on, the suddenly nothing is happening and the user doesn't know what's going on. Why is it not doing anything? So he or she will complain the program is not doing anything. So that would be a problem. When the cin statement is executed, the system is going to wait for the user to enter the data, but the user doesn't know that it's waiting for the data. Users don't know anything about programs. You have to assume that. So what we need to do is, I already explained that. So what we need to do is, all right, before I go into that, if you need to get two numbers from the user, then you could write C in num and then C in rate separately. If you do it this way, then it'll wait for one number. After you enter that number and press enter key, it'll go on to wait for the next number. You type the next number and press the enter key, then it'll move on. But instead, you can write it as write it in one statement like this: cin num and then rate with the two separate arrows. This will get both data at the same time from the user. The numbers have to be separated by a space. So if this is how the program is written, the user can enter two numbers with the space in between. If you don't put a space, then it'll become one number. So that's how you get more than one data. Now, going back to the point I made, if you actually have a cin statement in a program and run the program will stop running when it hits this cin statement, and the user may not know what's going on. So that would be a problem. So what we have a solution for that, which is to use the cout statement right before the cin statement. That'll put a text on the screen saying, enter the data now. So if you put that text on the screen, then the user knows that the data is expected, so he will enter the number. So that's the way to do it. So before every cin statement, you would write a cout statement that tells the user what is expected. So here is the program. This is going to be, so this is a better version of the program that will add two numbers. This program is going to be good for adding any two numbers that the user has. So here's how it works. Declare the variables, and one cout statement says enter an integer followed by a return. You really have to tell the user exactly what to do. And then when the user will see this, when this statement is executed, this instruction will be on the screen, and the user knows what to do. So he's entering a number. When he's entering a number, our cin statement is right there already. I mean, system is right here at this line, waiting for the number, and user already knows that he's supposed to enter a number. So he will enter the number and press the enter key, and now that number will go into num, and then this will appear on the screen. Enter a floating point number followed by a return. And when that is on the screen, system is already here and waiting for the number. And so the number user enters will go into this variable. Now it will produce the addition, and it will put the answer on the screen with this description. That program is now good for anybody to use to add any two numbers. So this is what we call interactive program. It would appear as if the system is interacting with the user, but the programmer made that happen. Programmer makes the computer appear to be talking to the user, but it's a program. So we can actually write the program to interactively obtain all the data and process the data. So
is there a way to save user input?
The user input will be stored in those variables, so they are saved. Okay.
Like on the computer, not on the compiler.
whatever the user, no, the user, whatever the user enters will be stored in this variable, which means in the memory of the computer, there is a memory cell called num that has the value. That's all. There is no other saving. Okay. There's no need to save whatever the user enters. Only for the program to use, the data has to be there. So it stores the data in these variables, and then it uses in this expression, and that's all we need. So there is no other saving. They're all in the memory. So it is in the memory, so it'll be there as long as the computer is still on, and the rest of the program can use them. Other than that, there is no other permanent storage of those values. Okay, so you already can easily see how it works. When this cout is executed, there is this on this screen, and whatever the user enters will go on the next line. It goes on the next line because I had this \n. Remember, everything you had to make sure everything looks and works nicely by throwing in everything, throwing in these ENDL and \n and things like that. So if I didn't have the \n here, then whatever the user enters would go very next to this this text. Enter the integer, enter an integer, the number will go right next to it without even a space. I personally don't like that. So that's why I made sure to put \n so that cursor will be on the next line when the user is typing the number. That's why the 24 is appearing on the next line. And then because the user will press enter key, the cursor will go to the next line before writing the next text, enter the float number. That's because of the enter key user is entering. So after that, because of the \n I have here, cursor will go to the next line when the user types the number. So the interaction will appear as exactly as you see on the screen. And the answer will appear on the last line after the interaction. So this is how it will appear on the screen if you write it this way. All right, so let's look at another example, another way of writing it. I want to get, instead of getting one data at a time, like I did here, enter an integer and then get that stored in num, and then enter a float, get that stored in val. Instead of that, what if I want to get both numbers at the same time? I can do that by writing it this way. Float val sum, and then cout, enter an integer and a floating point number with a space in between. Now notice that I'm writing several arrows to split that sentence into several sentences, because I cannot write a whole paragraph on one line. I have to break it. If you need to break it, you have to write them as separate strings. You cannot break the line. In other words, if you write without this like that, that's not going to work. It'll be error from the compiler will produce error message. So I have to break it into separate lines, separate double-quoted text if I have to write a long line like that. So I'm saying enter an integer and a floating point number with space in between, followed by return. You have to produce you have to say all that so that the user knows exactly what to do. So when that text is on the screen, the system is here waiting for the number. And now the user will enter two numbers separated by space, and this will read that. And then it will produce the sum and then put the answer on the screen. Everything will work fine. You don't, if you're expecting like 5 numbers, you don't want to write 5 lines, enter the next number, enter the next number, Instead, you can say, enter 5 numbers separated by space. That's why this feature is there. Okay, so now we need to do a little exercise. Write a program, shortest possible program, to obtain two-digit integer from the user and to print the sum of its digits. So you can expect that the user will enter two-digit number. You need to calculate the sum of the two digits. So that means you have to separate the two digits. You learned in the last section how you can separate two digits. So I hope you remember it. So let me see if you can write that. Okay, let me see if anybody remembers how to separate last digit from an integer. What's the easiest way to separate last digit from an integer? We did that in the last class. You have been all muted, so if you are speaking, you need to unmute yourself.
Isn't it minus 100?
Minus 100.
Point 100. It depends on the place where you want it, right?
No, my question is a number like an integer like 367. Whatever I do should separate this digit. Just get that digit. Even if the number is a two-digit number, like 26, I need the last digit. What is
Isn't it dividing by 10 or by 100 in order to get the single digit?
Yes, I think you have the right idea, but you haven't said it right. Did you do what? Divide, or did you say
Divide.
divide? Okay. If I divide by like 10, you mean?
Mhm.
Okay. 26 divided by 10, sorry, divided by 10 will be 2.6. What do we do with that? The dividing is the right technique for getting the first digit. Like if I want to get the first digit from 26, I divide 26 by 10 and assign it to integer type variable n, then I will only get 2. See that? 26 divided by 10 is 2.6. And when you assign it to integer variable, only 2 will be stored in n. So n will pick up the first digit. Okay. So that is the right answer if it is separating first digit. Now, how do I separate second digit?
Divide by 10, then modulus 10.
Divide by 10 and then take modulus 10. If you divide by 10, it's 2.6. And you cannot use modulus operator on a floating point number.
You would do modulus on just 26.
Just the modulus,
Modulus
right?
10, yeah.
Yes, if I take modulus 26 modulus 10, that'll be equal to 6. Remember from last class? 10 goes into 26 2 times because there are 2 10s in there, and remainder is 6. So modulus is how you get this last digit. So you need to use division to separate the first digit. You need to use modulus to separate last digit. Okay, so can you now write the program? if anybody has the program, you can show it to me by putting it against the camera.
I wrote one in the chat.
Okay, oh, in the chat, okay. Um, the problem is that to get to chat, I have to stop sharing. So I'm going to go out for a second. Oh, hold on. All right, yeah, I found it. See next. You're asking the, okay, here's the, I hope everybody can see that. This program asking user to enter two separate numbers, X and Y, and then adding them. Now that's not what the problem tells you. The problem says you can only get two-digit number, one number from user, and then you have to separate the digits yourself. So that's not quite right. Zoe, you still have that question? Do you want me to answer that?
Yes, please.
Okay. But the numbers will be entered on the keyboard. When the program runs, the system, whenever CIN statement is executed, the system will wait for the user to enter a number on the keyboard. So what the user enters on the keyboard will appear on the screen as well. And then when he presses the enter key, the number will be taken into the memory, and then system will proceed to the next line of the program. It's when the program is being executed, the system will wait for the user, and the user will enter it on the keyboard. That's how it works. Your next project is going to involve this interactive program, and you'll be able to see exactly how it works. Unfortunately, I can't show you right now because it'll take too much time, and also I'm working with the Mac here, so it won't be useful to you. All right, so okay.
Professor, it's a little strange to type it in the chat. Could I show you?
Yeah, go ahead. All right, one student has a solution. I'm going to take a look. Okay. Y is integer, and did you mean to say y equal to x over 10? Don't you have to divide to get the first digit?
Oh, yes, I did. Yeah.
Yes.
But other than that.
Okay, other than that, the next line is right. You're getting the second digit, and then you're adding, and then, yes, that's correct. Very good. So only thing missing is dividing by 10. All right, before I proceed, I'm going to go back to the previous example. Zoe, you asked a question, where do you enter? And so that's what I explained here. When the program is being executed, when you execute the program, this black window comes up, right? The black window is where this text will appear. Enter the integer. And then you type the number on the keyboard, and the number appears here, right? You press the enter key, right after you press the enter key, this will appear on the screen because of the program written that way. And now it's waiting on the next line to get the number, and you enter the number on the next line. Then you press the enter key. It'll use those numbers to produce the sum. And then this statement will produce the answer on the screen, which appears on the next line right here. So all this will be going on that black window that you get. You know, when you run the program, the black window comes up. In the last project, the black window showed the answer. But this time, the black window will wait for you to enter the number, and so on. All this I have written on the screen here will be happening on that black window. Okay, so you can even you know how to run a program. So you can even run this program the same way you ran the last program. You will see exactly how it works. I never had to demonstrate in class exactly how it works, so I was not prepared for that. So did I answer your question, Zoe?
Yes, thank you.
You're welcome. All right, so moving on to that exercise, this exercise. Let me write the program on this on the board. Basically, you need to begin with the main and then declare your variables. We clearly need a integer variable for the number that the user will enter, and int m. That's where I'm going to store the data that the user will enter. And I'm going to use D1 to represent digit 1, first digit. 1 second. D1 for the first digit, D2 for the second digit, semicolon, and then I need to ask the user to enter the data. I had to get the data before doing anything. So enter 2-digit number followed by return. All that I have to say here. And then cin m. So now m has the data, a 2-digit number. We can assume that it is 2-digit. Then I need to do D1 equal to m divided by 10. Now, I don't, see the m is integer, right? 10 is also integer. If I leave them both integer, this division will produce the first digit, right? If m is 26, m over 10 will be 2. So this will produce first digit. And that's what I'm storing in D1. Even if this division is going to produce 2.6, then I'm only picking up 2 in D1. Now D2 will be my second digit. All I have to do is m modulus 10. So that'll be my second digit. And now the problem says you need to print the sum of the digits. So I can say cout sum equal to, I can even do the operation right there, D1 plus D2. So cout D1 plus D2 is right. There's nothing wrong with that. I don't need to write another statement saying D1 plus D2 should be stored in some other memory. It's not necessary. Simple operations like this can be done right there in the cout statement. So this will print the sum of the 2 digits of the number. So user is only entering one number here with 2 digits, and I separate the digits here and then add them up and print it. That's what you're supposed to do. Any question on that? Okay. So that basically finishes the interactive programming. And your project, there's a project, your course calendar tells you what the project is. And that will be due let's see, today is Wednesday. Yeah, next, you should be able to do it Monday, because it doesn't, I mean, it's not a very long program. It's just interactive program, but very simple. So it's due Monday. I'll be putting the link up today, so you can submit that anytime. To finish this section, we have to understand constants. So I'm going to do that next. A constant in a program would be something that will not change within the program. So while the program is running, that number should remain the same. So what are those? What are such numbers? Numbers that are, some numbers that are key numbers in math, like pi. If you need pi in your program, then you have to assign the value for the pi yourself. Computer doesn't know pi. Your calculator has pi. That's because it's programmed to understand the pi, but computer is not programmed for anything. So you have to provide the value. So this number 3.141592654 is the exact value of pi. And if you need it, you need to throw that value into a variable. You had to store that value in a variable name. Similarly, E is another number we use in math very often. So if you need that in a program, then you have to store this value in a name E. The name you can choose, this symbol cannot be used as a variable. So you have to use the word like pi, pi. But you need to assign that value to that variable in the program. But if you make it a variable, then there are some issues with that. So I'm going to explain that next. Why pi should be a constant in a program, not variable. So here I'm using pi as a variable. This program, say, this program will find the area of a circle whose radius will be entered by the user. So this program is good for finding area of any circle whose radius will be entered by the user. So it's good for finding area of any circle. To do that, I need to introduce the pi. So float pi equal to this. I had to provide that value. Then there are two other float type variables, and asking the user to enter the radius of the circle, read it into the variable radius, and then calculate the area equal to pi times radius times radius. Now remember, these have to be in this order. If this statement is missing, then this statement cannot work. There is no radius. Radius has no value. So that statement has to go before this statement. This statement uses radius, so C in radius has to be before that, so that it will get the value of radius from user. And now you compute the area, you write the area. So this will work fine. It'll produce area of any circle user has. The only thing here is this pi is declared as a variable. When you declare something as variable, it can be changed in the program. That's what variable means. The value can be changing within the program. If you allow the value to change within the program, then it can be changed accidentally. Accidentally, it cannot happen in a small program like this. I mean, in professional programs, you write pages and pages of program, and you may accidentally have change. You may accidentally change somewhere in the program something like this. I accidentally write without realizing that I already have the variable pi. I end up using something like pi equal to 5. I use the pi as another variable, declare pi as another variable, because I forgot that I am using pi already. So this will go unnoticed. and the rest of the program will use 5 as the pi value of pi. So that will be a problem in professional programming because you are using so many variables and program is so long that you can accidentally end up using the same variable again or modifying the variable pi somewhere accidentally. So to prevent that, the C++ language allows you to declare something as a constant. If you declare it as a constant, that means you're saying this name should keep this value forever. It should not change. This value should never change. That's what it means. So how do you do that? You do that by putting the keyword const in front of it. If you're talking to someone, please unmute yourself, please. Sam, I believe there's noise coming from a background. Sam, can you mute yourself, please? All right. So the name pi, whenever you want to use pi as a constant, you can say it's a constant. And if you make it a constant, then if the pi is being changed anywhere else by the programmer, the compiler will reject the program. Compiler will say error. So let's see how to do that, how to make it a constant. Here is one way. You say const float pi equal to this. So the word const in front of it will tell the user, tell the system compiler that this name will hold this value forever. It should not change. And notice that the pi now is capital PI. That's why I said earlier in chapter 1, when we were discussing names of variables, I said capital letters are reserved for constants. This is what it is. When you're declaring something as constant, you use capital letters so that anybody reading the program knows that it's a constant. That's why we do that highlighting. So this is one way of declaring a constant. Another way is to put a pound define at the top of the program where the pound statements go. If you do pound define, there's no equal sign anywhere, if you notice. Pound define and then a blank space pi, a blank space 3.1415. So if you write that at the top, that will be also declared, that'll be considered a constant. It'll never be changed anywhere in the program. So 2 ways to declare a constant. Remember, if it is a constant and if it is changing anywhere else, the compiler will reject that line as an error. That's the purpose of making a constant. So let's do. Oh, we're out of time, but so we cannot finish this. Well, let me quickly write it on the screen.
Is it possible to have user input on Xcode? Because I'm having trouble doing it.
Yes, no matter what compiler you use, the interaction will work the way I explained. Okay. Okay, so if you want to get data from the user, the balance from the user and print the new balance after interest, then that will be this main and then float for balance, const. My pen is not working good today. Const float rate equal to 0.08, 8% interest. That's why the rate is there. Rate is declared as constant. And then C out, ask the user to enter the balance. And C in balance So now you have the balance, bank balance in this variable. And now compute BAL.
To go, we have classes now.
Yes, I'm finished. I'm just quickly finishing this and I'm done. So BAL times rate is your interest. Add it to BAL. Now that's your new balance, right? To the original balance, I'm adding BAL times rate. If I put that back in BAL, then now balance has been changed. The balance in the balance is now changed to have all balance plus interest goes into balance. And now see out BAL, this will print new balance because you have already changed the balance to have new balance and close. That's it.